will discuss now design parameter estimation of non-woven fabrics. Let us say that the technical requirement is fabric basis weight should be 120 gram per meter square, mean pore diameter 45 micron, or porosity should be 70% and fiber should be nylon. Suppose this is what is given. Now, we need to find out what should be the fabric thickness and what should be fiber linear density. So, some technical requirement or needs are given and the manufacturer has to manufacture this. So, he has to find out two important parameters, that is what should be the thickness of the fabric. So, that he set his machines to make sure that he get that thickness, and the other important information he needs, that what should be the right fiber linear density that he should choose. So, that the mean pore diameter is around 45 micrometer. So, let us go about this. Now, here when it comes to the thickness, estimation of thickness, then the fabric basis weight is related to thickness, fiber density and porosity. That equation is stated here. And what is porosity? Relationship between porosity and fiber packing density, this is also stated in the another equations. So, here that means basically we can make use of these two equations to find out what should be the thickness of the fabric. So, input parameters are G, that is the basis weight, the porosity and the density of the fiber. Fiber is given nylon, so we write the density 1.14. If it is said polyester, we change the density to 1.38. Whatever fibers are given accordingly, density will be there. From there, we can say now that since G is this as stated in the previous equation, we can find out what should be my T, very simple. So, we make use of that equation to find out the value of T, which gives me 0.35 mm. That means, we have to make a very thin fabrics or only 0.35 mm in this particular case. The other aspect is estimation of fiber linear density. Here we make use of two equations. One is equation number 3. This is related to that the average pore diameter is related to fiber diameter and porosity by this equation, and this was developed by this gentleman. So, we make use of this, and diameter versus denier relationship is also given in equation number 4. This is a very straightforward equation. Many of you will be knowing it also. You must have been taught also in your maybe some courses where the relationship between diameter and denier of a fiber have been derived. So, if we make use of these two equations to find out what is the linear density of the fiber to be. So, if this is the model equations, input parameters are this and fiber linear density is. So, input parameter is d, p mean is 30 micrometer, that is what we are taking it, and from there if we try to find out the value of linear density dp mean, make use of these equations. So, from there I can find out what is should be the diameter of the fiber, because the porosity is something which we have assumed to be 0.7, and therefore, the packing fraction of fibers, the solid volume fraction is 1 minus epsilon, that becomes 0.3, this is 1 minus basically 0.7. From there we can easily find out what should be the diameter of the fiber, that is 23 micrometer. And using fiber diameter linear relationship which has been stated, we can find out what should be the diameter square. So, if we go this, see diameter square, we can write like this, these equations, and so fiber linear density, that is the denier or fiber denier, basically means we rewrite the same equations and from there we substitute the values, we will be getting the fiber linear density in terms of denier. That means, in this case we need to use a fiber denier of 4.26. So, we have to make use of the relationship that has been developed by different authors. Sometimes they may not be available readily in textbooks, we may have to consult some research papers and we have to make use of them. So, that at least we get an estimation of 4.26, that is the linear density of the fiber that have to be, we have to choose. So, if we choose this denier of fiber and we make the thickness whichever we have got it earlier, that thickness was how much? It was 0.35 mm. So, now it goes to the actually the production team, they have to arrange the machines in such a way or they have to set the parameters of the machine in such a way that they should be able to create a non-open structures from 4.2 denier fibers or close to 4 denier fibers, and the thickness has to be around 0.35 mm. That is what the whatever results we get it. Now, sometimes we may need to add slightly modify the specification or requirements. Let us say basic weight there is no change. We say that porosity should be in this range 65 plus minus 5, somewhere in this range, not necessarily exactly 70. Pore diameter can be in this range. We are not giving a fixed diameter, fixed value. Thickness due to some other reason has to be less than 0.30 mm, and fiber linear density should be less than 5 denier. That means, instead of having fixed value, we are now changing the specification. So, that we have values which should be either in this particular range or sometimes less than this or sometimes maybe more than this. Such kind of situation may arise while trying to find out an answer to the problem that has been posed. That in these situations, how to decide which fiber linear density we should choose and what should be the right thickness. Now, this one can be solved using those equations on an Excel. We can have Excel file and make a table like this as shown it here. Fiber linear density, fiber remains same. So, density does not change. We assume porosity, not assumed, as it is been shown 65 plus minus 5. So, we take 3 values 60, 65, 70. GSM does not change, thickness less than 30 mm, that is the requirement, it has been stated 0.30 mm. Mean pore size should lie in the range of 20 to 30. So, we are taking 30, 25 and 20, and we are repeating, then we are calculating the fiber denier, and we are trying to work out the values of fiber denier. So, we have created 9 set of combinations, and we are calculating what is, we are calculating two things. One is we are calculating the thickness, estimating this, and also are estimating the denier, these two. And if we look at this table now, if we look at this, here this is your, the answers are given in this column and this column. Out of these answers, we have to see which answers are actually satisfying the requirements. So, in the first row, if you look at here, thickness is greater than desired, fiber deniers also is less than, fiber deniers is less than, this is okay, but thickness is greater than desired. So, therefore, we have to reject this solution we are rejecting. Why? Because fiber denier it is meeting, but the pore diameter is more than 30. So, therefore, obviously, this choice is not possible. In this case also this choice will not be possible, in this case these choices are not suitable, because the thickness is going beyond the required value, that is 0.30 mm. It has to be 30 or less. When we go to the next, here what we see here, that the thickness shown by green, that means it is meeting the requirements. Fiber denier has become 5.8, it is more than 5, and hence fiber denier is greater than desired. So, this is also not acceptable, this is also not acceptable, this is not acceptable. The third choice in this case, this is meeting green, this is also meeting, this is green, but denier is more than 5. So, this is also not meeting our requirement. So, therefore, in some of these cases we see that we are not really in a position to, in this case they are not meeting the requirements. Therefore, we say that this is not going to work. So, wherever you see the green colors, these are the combinations where it is meeting both the requirements. Therefore, the acceptable combinations are this one, that means we can use nylon fiber, but that porosity has to be then 65, and in that case if we choose a fiber of your of 4 denier, then it meets the requirement. 4 denier fiber, and you have to make a fabric whose thickness should be 0.3 mm, then it will meet the requirement. Similarly, we go to the last one, where we see that in the first case we have to reject it because thickness is more than 0.3, but for other two cases what we see here, in both these cases, in this case and this case both are acceptable, because fiber denier wise it is less than 5 and thickness wise is also 0.3 or less. So, we get 3 answers now. Either you choose 4 denier fiber, make a fabric of 0.3 mm thickness, or you took 2.6 denier fiber, make a fabric of 0.3 mm thickness, and 3.3 denier fibers, and make a fabric of 0.26 millimeter thickness, they are going to work. It will give you the right kind of mean pore diameter and porosity, everything is going to meet. Fiber linear density also is going to meet, thickness value also it is going to meet. So, these are the constant, you can say this is one constant, this is another constant. These two are the constants, the others are the requirement, and if we make use of the Excel files, so you can create your own Excel files and you can get the answers. Now, let us go to non-woven filtered fabrics. Performance requirement of a filter, yes, some things are stated here. One is the back filter. Now, in back filter, the most important requirements are pressure drop at specified airflow rate, heat resistance, filtration efficiency and dust capacity. Secondary requirements are weight and thickness, resistance, antibacterial properties, feasibility of burning or recycling, ability to deodorization. These are the secondary requirements. Liquid filter, the pressure drop at specified flow rate is always important. Then heat resistance could be important depending upon what is going to be used. Chemical resistance also could be important. Filtration efficiency is always important. Weight, thickness. So, these properties are stated here. These are generally these are the requirements for filtered fabrics. The structural and material parameters which are important are also stated here. If the requirement is pressure drop at a specified air flow rate, then the structural parameter which would be important are porosity, thickness and filter area, these three. Fiber parameters therefore, which will be important is fiber fineness, cross sectional shape. So, what I am saying, this is the performance criteria 1, 2, 3, 4, 5, 6 and we are associating it with the structural parameters and also the basic parameters of the fiber. So, pressure drop depends upon the porosity, thickness and the overall filtered area and also depends upon the fiber fineness as cross sectional shape. Heat resistance mainly is decided by the heat resistance of the fiber. It is the basic fiber property that is important. Structural parameters do not have much role. Filter efficiency mainly depends on structural parameters like pore size, its distribution, thickness of the media and whether the structure is layered or not. Fiber parameter responsibility of fiber fineness, cross sectional shape like this. So, similarly, now we are writing that if this is the requirement, what are the structural parameters which will be important for this requirement and what could be the fiber parameters which are responsible also or which can affect the performance requirements. So, such kind of table is there. So, this is going to also help. Other properties like antibacterial properties, it depends upon the intrinsic property of the fiber, resistance to chemicals depends on the intrinsic property of the fibers. Now, what we little bit we should be aware of the few theoretical aspects while we are trying to design a filter fabrics. Relationship between flow rate, pressure drop, permeability relationship. Now, this is a very standard equations, Darcy's law, which states that Q by A equal to K into delta P by mu into Z. And what are Q, A, all these are stated here. So, this equation the person should be familiar. How to deduce this equation? We are not going to discuss. We straightway take this equation and if we rearrange them, we can rearrange them in terms of delta P is what is Q by A mu into Z by A into K. or we can write in this way also, because q by a is v, that is phase velocity, or we can write thickness in terms of other parameters. So, same equations written in different way, so that whatever is known to us, we will put those values on the right hand side of the equations, what is unknown, that is on the left hand side. And this, so these are this basic equations is going to very useful for filter. Now, this is another very interesting equations, permeability. Permeability through a fibrous media had been the focus of research by many researchers. Many researchers have done, and a lot of complicated equations have been developed for this. One equation which is quite, people use it, and I found it also quite suitable, because initially we have to go for estimations which will be quick in nature, and we arrive at some values of practical importance, and then we can develop a product. So, permeability is related to fiber diameter and solid volume fraction, that is psi. This equation has been developed, and this is very developed by whom? Developed by Davis. There is a standard reference, anybody can just search on the Google, you will find these equations. And what is this solid volume fraction? Most of you will be knowing, simple density of fabric by fiber density relationship, and this ratio is known as the solid volume fraction of fibers in a nonwoven structure. Now, we make use from these equations. So, this is one basic equations from where we write what is the value of k. This is another equation for k, permeability. Now, from there equating equations 4 and 6, we write that the permeability is equal to this, something which can be measured by doing some experiments. Obviously, the left hand side also can be measured. We can measure diameter of the fibers, we can find out what is the solid volume fraction. Anyway, so therefore, we get an equations which is this. Now, this is the equation which will be using to find out what we are whatever the fiber parameters we need to estimate. Now, we are going to estimate that, design parameters estimations, and we take an example. Example is that filter restrictions, that is restriction of pressure. The pressure drop is 0.2 kPa, that is 200 pascals. Flow rate is 300 meters cube per minute, and flow rate to cloth ratio is 4. The back dimensions are given 5 meter in length, 0.1 meter in diameter. What we have to estimate? What fiber we should use? Fiber diameter, how much it should be? Fabric basis weight, what it should be? From here, how do I go about, so that we can get the answer of these questions? So, airflow to cloth ratio is given is 4, that means the area of the fabric that is required is be 75 meter square. Q by A is equal to 4, therefore, A is going to be Q by 4, that is 3 by 4, 75 meter square. So, this is the first thing we need to know, and then when it comes to fiber selections, we make use of such kind of table. See, qualitative values are stated: fiber, maximum temperature, physical resistance, chemical resistance. So, this data, as we have said, that G means good, F means fair, P means poor, E means excellent. So, the in the qualitative scale we can say the various properties are stated. From here we can see that for the filter fabrics, which will be very suitable for this, is polyester and nylon. We are not going into details, keeping in mind what? User environment, cost, manufacturing easiness and durability. Keeping in mind all this, let us say we ultimately land on these two fibers, polyester or nylon. So, we can choose either polyester or nylon, and then we go ahead keeping in mind all these factors: environment, cost, manufacturing easiness, durability. So, there are many fibers have been given, some of them are very costly, some of them can be used in specific situations. In a heavy high temperature applications, obviously polyester and nylon cannot be used. We have not really stated in details that what is the user environment. So, we can skip that, just let us think that these two fibers are suitable, keeping in mind the rest of the parameters, including user environment. That is not very high temperature kind of applications that the polyester nylon cannot bear, not that kind of situations. Now, we make use of these equations, which we have already stated. We already know this equation we have written. Fiber volume fraction we have chosen to be 0.3. So, if we substitute this in these equations, we get a figure 26.41. So, 26.41 we put in the in this equation now, and we put rest of the values on the right hand side of this equation. The only unknown is Z, where Z is the thickness of the fabric that we have to find out how much should be the thickness of the fabric. So, since some of the parameters have already been given, like what is the delta P should be, that is already given, and how much Z we need, that we have to find it out. So, we have taken that also, and let us say maybe we have been also given what is the diameter of the fiber, that also, or the denier of the fiber, let us say, is given. We can find out what is the diameter from here. So, because diameter square is coming here, delta P is 200, area is 25, this is the viscosity value, and this is the parameter Q, which is 5 meter cube per second, and this is the Z, which is unknown. So, here this is the diameter of fiber, that is dF, that is 1.7 10 to the power minus 5 meter. So, we can say what is the corresponding denier of the fiber. So, that is also initially that is the assumptions. You go with this, the value of Z that we find out is 1.85 millimeter, that is the thickness of the fabric in this case should be 1.85 millimeter. After estimating the thickness, the next thing that to estimate is the basis weight, and again this solid volume fraction is related to basis weight m by these equations. So, if we make use of these equations, we already see Z we have already found out, we need to know what is m. So, we find out m now, and we say the m value we are getting 765 gram per meter square. Now, in the bag area, this is the length, this is diameter. So, pi into d into L, this is the D, this is the L, this is the area of a single bag. So, how many bags we need? 75 by area of individual bags, that gives you a figure 47.7, that means we need almost 48 bags. And what will be the filtering velocity, that is phase velocity of the air, that will be flow rate divided by bag area, 5 by 75 is going to be 0.066 meters per second. That is how we can find out how many bags we require, what will be the filtering velocity. So, only assumption here was the fiber. So, we had to initially start with some assumed value of fiber, and we can make an Excel table and take different values of fiber, keeping other parameters constant, and can generate a table that if this is the fiber diameter or this is the fiber linear I choose, these are the values I get. Then if I change the linear density, whatever commercial values of fiber linear densities or deniers are available, we put those values and find out the corresponding values of thickness of the fabric, the GSM of the fabrics. We will get a basically a solution space we will have, that is we have multiple solutions for different fiber linear density that we choose, and then you get the corresponding values. So, once we have that solutions, we call it solution space, then comes the next step to choose one particular solution out of that, or maybe two solutions out of this, whatever it is. So, that is how we can go and estimate certain important parameters of related to the filter fabric design. So, with this we I think close this particular topic, and thank you all.